Is everyone ready? Let's get ready for chemistry! Let's say that you have the equilibrium that exists between hydrogen and iodine to make 2-hydrogen iodide, and you have starting quantities of 0.732 molar hydrogen and a starting concentration of 0.732 molar iodine, and you wanted to find the equilibrium concentration of all of the species. You would need to employ what's called an ICE chart. Now, ICE stands for Initial, Change, Equilibrium. If you have a problem and they don't tell you that you have any products, it's almost always safe to assume that there's no products to start with. This system is not at equilibrium right now because there are no products. So the only way for this system to reach equilibrium is for this system to gain products. Now it's going to gain X products. I'm not entirely sure what X is yet. And actually, it's going to gain 2X products. And then this is going to lose X reactants from the hydrogen and from iodine. It's not a limiting reagent problem because it's an equilibrium system. If this had been a fat solid arrow, it would have gone to completion and you would need to worry about which one's limiting. But because the system is at equilibrium, it's a different kind of problem. Now, what we know is this is going to end up being 0.732 minus X, 0.732 minus X, and 2X. 0 plus 2X is 2X. Then we'll need to write the expression, always starting off with the generic equilibrium expression, K equals products raised to their coefficients divided by reactants raised to theirs. Now we can start plugging in some numbers here. K is 0.56, and that's going to equal 2x squared over 0.732 minus x times 0.732 minus x. So when we solve for x, we can just call this 0.732 minus x squared, and then we can take the square root of both sides. And then we can multiply both sides by 0.732 minus x. And then we can combine like terms. So x is 0.20. Now remember that solving for x is not the end of the problem. What we were looking for is the equilibrium concentrations of hydrogen and iodine and hydrogen iodide. So the equilibrium concentration of hydrogen is 0.732 minus x, where x is 0.20. So the equilibrium concentration of hydrogen is 0.53 molar, and that's equal to the equilibrium concentration of iodine because it's the same expression here for both of these. The equilibrium concentration for hydrogen iodide is 2x, where x is 0.20. So the equilibrium concentration of hydrogen iodide in this problem is 0.40 molar. So when the system comes to equilibrium, hydrogen will have a concentration of 0.53 molar, iodine will have a concentration of 0.53 molar, and hydrogen iodide will have a concentration of 0.40 molar. So we're going to use an ice chart to figure that out. Initial concentration, change in concentration, and equilibrium concentration. Now when you use an ice chart, it's very important that you're working with either pressure or molarity. You can't work with moles. You cannot work with moles when you're doing an ice chart for an equilibrium problem.
Is everyone ready? Let's get ready for chemistry! Yeah, 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 yeah.